welcome back to the Infodump, the series where I do a deep but not necessarily scholarly dive into a particular topic. I really slurred my scholarly there. You can tell that I'm tired as all get out. Also, I had a plan for this episode, and then when I sat down to actually pull together notes and write a sort of ish script for it, completely fucking fell out of my brain. So this is much less organized and sensible than it should be, because I literally, I've had an idea of, okay, this is what I'm gonna do for for the next episode of the Infodump. This is how I'm gonna lay it out, etc. This is some stuff that I feel like I really should have talked about last episode, but I didn't. So, yeah, apologies for that, obviously. Also apologies for the sort of abrupt launch into the gameplay there if you are actually watching and don't just have this on as a podcast or in the background. I forgot to actually set up, recording for 10 minutes. Obviously has been a little bit of a theme with me lately with the good old Hearts of Iron half episodes that I've had to do in liberating the world, because I've just... Oh, I don't have the webcam, so you can't see the gesture that went along with the sound effect, but I, swing and a miss, just whiffing. God, I'm so fucking tired. Yes, I'm literally recording this at midnight, which, to be fair, is earlier than I have recorded some infodumps in the past, but those are the ones that I actually had a fully fleshed out script for before recording the episode. So, yeah. So last week, of course, we talked about fundamental particles, and this week is going to be a double feature. So this episode is going to be a little bit off-the-cuff-ish. I just want to cover a few sort of more complicated, very quantum-level things. Oh, I remember. And of course, this whole intro about me forgetting stuff is going to stay in, because that makes for good content, TM. At least, in my opinion. But yes, I wanted to talk about quantum interactions, because those are things that are very commonly misunderstood, and they are the biggest sort of mindfuck in quantum mechanics. So, I talked the last couple episodes about how quantum mechanics does not work the way that you expect regular mechanics to, because regular mechanics is the result of all the unlikely things that can happen in quantum mechanics basically being reduced in probability to the point where it's functionally zero. However, once you are looking down at that quantum level, you can actually see, quantum mechanics. We touched on it a little bit with particle-wave duality, but I feel like it is worth delving into it a little bit more. So, first things first. This is a big part of why I feel it is valuable to perhaps not start teaching physics with quantum mechanics, but to at least include quantum phenomena at early levels of science education. Because if you go into this without the amount of mental flexibility that you need, then it's just not going to make any sense whatsoever, and it's going to hurt your brain. children tend to have a great deal of mental flexibility, certainly more than adults tend to. And even if they don't understand all of the stuff that's being said right away, you can at least prime them to be able to understand it later on when you're actually teaching quantum mechanics as, say, a unit in college or in high school. So, particle wave duality is one example of what is more generally called quantum superposition. Now, if you know almost anything about quantum mechanics, it is probably about quantum superposition, because that is where we get probably one of the most famous experiments, or thought experiments, I should say, in human history, and that is Schrödinger's cat. Now, the funny thing is that Schrödinger originally created this thought experiment to show how ridiculous the prevalent interpretation of quantum mechanics, the main way that we try and make sense of all this weird stuff going on, handled superposition. So that predominant way of thought essentially held that the quantum events, like quantum systems, when you're not observing them, a system sort of exists in all possible states at once, and then it randomly just decides one to be in when you look at it. That is a sort of basic observation level understanding of quantum superposition. The way to think about it is that when it is not undergoing some form of interaction that requires it to be in a particular place, the probability waves are such that essentially it is spread out across all of its possible states. So, for instance, if I were to have a single electron, let's say, not attached to a nucleus or anything like that, just a lone electron floating in the void, and it gets hit by a photon. Well, does it get hit by a photon? Yes-ish. It gets hit by the photon where the wave of probability of the electron's location and the wave of probability of the photon's location align. Now, of course, they align over a wide area. So then, more stuff comes in. You have to really narrow down to that binary, you have to bring in a more and more complex system, which means more and more probability waves interfering with one another, creating these areas of nope, definitely not, and definitely yes, creating essentially a binary set. And then as to which of the options of the binary set it is, well, that is about what our probability waveform as the observer and the probability waveform of the system line up with. So, essentially, and this is the part that gets really mindfucky about quantum superposition that can be kind of hard to grasp, but once you do grasp it, it's very much mind-expanding. When we observe a quantum phenomenon and we think that the quantum superposition has collapsed down to a single state, that is incorrect. What has happened is that our probability wave has harmonized with the probability wave of the electron and the photon and the rest of the system, such that we are now part of that system. So, when we think we are seeing a superposed system collapse, in actuality, we are now part of the system, and the reason we think it has collapsed down to one state is because we are experiencing a part of our waveform that has aligned with the part of that system's waveform. And you can keep building up and up and up, and those, different waveforms all align and interact and combine and harmonize such that on a macroscopic level, everything works out classically, the way that we expect it to, with things being discrete physical binary objects. It exists or it doesn't. But all of that is just because at a quantum level, waveforms have harmonized. They have come together, and we have ended up part of the system. Not, destroying the system, not causing it to collapse down to a single state, but merging with it. And like I said, that can be really mindfucky to try and wrap your head around. Obviously, it is incredibly counterintuitive, but the more you think about it, the more sense it makes. And the harder you think about it, the less sense it makes as well, unless you have a pretty good understanding of all the different possible theories as to how superposition actually works. It does sort of provide an extent of grounds for the many worlds interpretation of quantum mechanics, which, full disclosure, is an interpretation that I personally ascribe to. Essentially, the many worlds interpretation says that there are not parallel universes, but rather different parts of the universe as a whole's probability waveform, where, that the whole universe has its probability waveform made up of the harmonizing of all the probability waveforms within it. So just as our probability waveform as individuals have parts where, a superposed electron gets hit by a photon or doesn't, the universe has, it gets hit by a photon or it doesn't for every single quantum event. So whenever a quantum event happens, the universe's waveform gets that little bit more complex, that little bit more wrinkly, as it were. And so you end up, again, not with parallel universes, but with essentially a sideways in time sort of deal, where every quantum event, again, specifically quantum events, any other non-quantum event, toss out the window. Any quantum event that's of literally no significance whatsoever still creates a fork. So every quantum event creates this sort of fork where the probability of it happening and the probability of it not happening become discrete parts of the universe's waveform. And of course, we only experience the part that we are, experiencing, because that's the part that the us we think of as us, that little slice of our broader probability waveform, lines up with. Obviously, talking about this stuff starts, feeling like it's veering into, the mega stoner, awaken your mind to the seventh dimension type of stuff. I'm very much of the belief that it is impossible for us to really truly grasp beyond just the slice of our own probability waveform that we experience, because, that's sort of what defines it. As soon as we try and reach beyond that, we're not pulling ourselves up, we're just dragging everything else down and not actually accomplishing anything. Does that mean I think that, those sorts of inquiries shouldn't be undertaken? No, absolutely not. If we can drag stuff down, maybe we can analyze and understand it. But I don't think that we will ever be able to, actually experience, what we are going through in other splits of our probability waveform. Maybe we do. Maybe that's, one explanation for stuff like deja vu, or for stuff like, the Mandela effect. I mean, there's a whole fucking movie dedicated to that, but, by creating that sort of artificial coherence, I don't know. Current brain science does seem to strongly suggest that quantum events are very much responsible for what we perceive as consciousness, which certainly lends credence to the idea that A, free will is possible in a universe that is deterministic outside of random chance, and B, that if we do indeed have a, quantumly based consciousness, that would help explain how consciousness seems to be so closely linked to things like superposition and observation, etc., and how, long, complex thing. It's more philosophy than science, unsurprisingly. I mean, the cutting edge of science is often more the realm of philosophy than of actual science, because, well, science is empirical, or at least it's supposed to be, and if we don't have any of the methods to empirically test something, all we can do is shout theories into the void and not get an answer because it's the fucking void. What do you expect? So, bleeding edge stuff is always going to be more the realm of the philosophers than the scientists. I think of myself as something of both in an armchair capacity. I'm mostly here just to talk about stuff that I find interesting, and that is the be-all and end-all of it. But, yeah, I think, broadly speaking, for the most part, quantum mechanics, quantum superposition boils down to, it's really fucking weird, everything is probability, and when probabilities align, we get entangled into the system. Not entangled. Entanglement is a separate thing that I'm going to talk about in a bit. That's why I've been so careful to not say it. We have now become harmonized with and enmeshed with the system. Maybe, definitely not entangled, but maybe, permanently linked. As for entanglement, because, me tripping on my words there is the best fucking segue I can do with the next to zero amount of prep I did for this, and by next to zero, I mean 0. But I did actually do prep like 5 days ago and then forgot it. So, it's fucking something, right? Anyway, entanglement, I have a real bone to pick. Not with quantum entanglement, but with the way that people tend to represent and portray it. Quantum entanglement physically cannot be used for communication. I know I have just broken every aspiring sci-fi writer's heart, but that is an unfortunate fact. You can't use quantum entanglement to bullshit your way through faster-than-light communications. All that quantum entanglement is the fact that when an event creates two particles with a particular variable called spin, so spin up and spin down, they will have the opposite variable, no matter how far apart they are. So, in a sense, yes, it allows for the faster-than-light travel of information if you're a real fucking idiot who doesn't understand how things like deduction work. Here's the thing. If you're working over long enough distances, well, you can pretty easily deduce a lot of information. Now, when you are working directly on, well, data that you are getting from light, or from, things that rely on light, then yes, you are limited to the speed of light. But, if we suppose that rather than, using quantum entanglement to measure one particle's spin and then know the spin of another particle way, way in the distance, you instead use the knowledge that gravity works the way gravity does to deduce that the center of the galaxy, the supermassive black hole, has an incredibly massive gravitational pull. Well, guess what? You've just gathered information the same way that you gather information with quantum entanglement. It really isn't that special. Like, yes, it's special because we can look at a particle and know information about another particle from any distance, you know, at the speed of measuring the first particle. But we can't change that value. We can't change what a particle's spin is, whether it's up or down. That's fixed. And even if we could somehow change it, changing one of the entangled particles would break the entanglement. Again, theoretically, because we can't actually fucking do it to test. But we can say pretty confidently that it wouldn't fucking work in the first place. We can also say pretty confidently that even if it did work that way, even if you were able to communicate spin up or spin down, yes, you would theoretically maybe be able to communicate faster than light. You know, if you could manipulate the spin of an entangled particle without breaking the entanglement somehow, some way, that would not mean you've got easy, faster than light communications. Because you would essentially have to have one of those for every bit that you want your computer to be able to calculate remotely, or, you know, every bit of data that you want to transfer. And here's the fucking kicker. You have to specially have those entangled pairs for every unit in the network. It's an inherently closed network. So you can't do a fucking quantum faster than light broadcast, you know, on open channels. You have to specifically send it to the recipients that you have the entangled pairs for, and you can't fucking add new ones later. Well, I mean, you can, but you have to physically add on more hardware. It's just a ridiculous idea that you could use quantum entanglement for communication. Now, what you can use for faster than light communication is quantum wormholes. Now, you're probably familiar with wormholes, particularly if you've watched Interstellar. Interstellar, despite its lackluster story at times, certainly does the best job of scientifically conveying what a wormhole is of any, you know, big movie, at least that I am familiar with. It's sort of like the way the 2001: A Space Odyssey really realistically portrayed space travel, right? Interstellar really realistically portrays wormholes. Essentially, they are holes in the 4, maybe more dimensional fabric of space-time, from one place to another. The thing being, because they're holes in space and time, they don't like to stick around even when you've got one open. You have to figure out some fucking way to anchor it. Now, actually, I say Interstellar does a really good job of portraying them accurately. Infinity War... Was it Infinity War? No, Endgame. Avengers Endgame does a good job of portraying how you can use them for time travel. That is not what we're talking about here. We're not talking about trying to shenanigan them for time travel. We are talking about using quantum wormholes specifically for faster-than-light communication. Bigger wormholes can be used for faster-than-light travel, yes, but they are virtually impossible to open in the first place, and then keeping them open requires more gravitational pull than the black hole at the center of the galaxy. So that's not exactly going to happen. But quantum wormholes pop up seemingly spontaneously all the time. There are some theories that they might be linked to quantum tunneling. The theory that I personally subscribe to is just space-time is a wibbly-wobbly mess. You can try to make it, all have a consistent spread, but because it's folded in on itself anyway, thanks to gravity, you're gonna get those little rips and inconsistencies and bits of bleed over, especially once you're looking at the primordial chaotic soup that is quantum level stuff. So these tiny little wormholes phase in and out of existence. They evaporate as quickly as they arrive, but if you can figure out a way to hold one open, well, especially if you can figure out a way to create and direct them, or again, just hold them open, then yes, you do still need to have the same sort of system of, okay, one for each, yada yada, but it's a lot more flexible because you can, open new ones and close old ones and whatnot. Sort of like an encrypted platform where if two people share their key, they can then communicate perpetually. It's the same sort of function in theory. So you can use these quantum wormholes, again, super in theory, if we can actually figure out how to stabilize and, harness them and get them to move consistently in space-time, like with the computer or the communication system of your choice. Yeah, you can send any sort of wave you want through there. You can send, well, not physical waves, but you can send electromagnetic waves, right? You can send photons, you can send electrons. Heck, you can probably send individual quarks and such through. Maybe even nucleons, if you really want to risk it, but I would not risk it. But the point being, you can use them essentially as wireless access points, more or less. So if you have a, mini wormhole, essentially, that's keyed to, well, the core internet hub, right? There you go. You've got a quantum, interstellar, faster-than-light internet, but it requires wormholes, not fucking entanglement. Anyway, I've really rambled on about this. I think that is where I'm going to stop this part of the double feature. I need to drink some fucking water and soothe my voice, and figure out what I'm going to do for the next episode. So, with all that said and done, thank you very much for watching and or listening, and I will see you all next time.